Look at this area from my 2D game. It's got some nice assets, but it's flat and lifeless. But just because the game is 2D doesn't mean it's doomed to be flat. We can add depth and make the world feel more alive by simulating the parallax effect. If you look out a car window while it's moving, you'll notice the closer that objects are to you, the faster they move. Distant objects like mountains will barely move, some faraway trees will move a little bit faster, and close streetlights will whiz by. That is the parallax effect. Now, game engines use cameras to decide what part of a 2D or 3D game's world to render and how it should be shown on screen. 3D games will automatically have the parallax effect because they use a perspective camera, which mimics how our eyes see the world. 2D games, however, use an orthographic camera, which means objects will be the same size no matter how close or far they are from the camera, and there is no parallax effect. This camera is important for 2D art since the assets are meant to be viewed head-on and not from the sides, so an orthographic camera prevents the assets from being distorted. Now, you might be thinking, well, a lot of 2D games still have the parallax effect, like here in Blasphemous for example, but this is actually fake or simulated parallax, as I'll call it. Objects in the background are coded to move slower and objects closer to the camera are coded to move faster. The result is a game that feels much more alive because a sense of depth has been added to the world, and although simulating parallax is really easy to implement, it might cause a big problem if you're doing it in an upscaled pixel art game like me. Really quickly, I want to thank everyone for the recent support. I haven't told you guys this before, but I actually quit my job to work on YouTube and game dev, which was probably a stupid thing to do because I didn't have much savings. But I have found something that I love to do, and only because of your guys' support on Patreon and just through watching the videos, I've been able to keep going and work on stuff I'm passionate about. So I just wanted to express my gratitude for that. And also thanks to you guys, I am thrilled to announce that for the first time ever, Barry's Development Hell has a video sponsor. Brilliant is an online learning platform, and I'm really excited to work with them because their platform of learning aligns really well with my channel's goal of learning how to code, how to make games, and just upskilling in general. Brilliant helps you get smarter every day with thousands of interactive lessons in programming, data analysis, AI, math, and even science. I particularly like how visual and interactive the learning is, which is something you just won't get from a textbook. And you can take that learning with you anywhere you go because Brilliant has an app where you can just bang out a few lessons whenever you get some downtime. Brilliant's freshly updated courses are a great way to upskill, whether you're new to coding or more experienced. I think you'll really enjoy the learning Brilliant has to offer, including programming with Python and learning to think like a programmer. If you like the sound of that, you can try everything Brilliant has to offer for free for a full 30 days. Visit brilliant.org/Barry's Development Hell or scan the QR code on screen or click the link in the description. You'll also get 20% off an annual premium subscription. Again, thank you everyone for your support, and thank you Brilliant for sponsoring this video. So, what's the problem with adding parallax to an upscaled pixel art game? Well, in my last video I talked about pixel snapping, and as a quick recap, pixel snapping happens in an upscaled pixel art game when you add smoothing to the camera. The camera will move in sub-pixel positions, but all other objects are forced to move in pixel perfect positions, and this difference causes objects to snap into position instead of moving smoothly into position. Adding parallax layers also makes the pixel snapping effect way worse because each parallax layer snaps into position at different times. I managed to remove the pixel snapping effect from the main layer of my own game, and you can see here the before and after difference. Everything moves smoothly instead of jittering. Now, the comments on that video are completely divided. Some people love the fix, some people hate the fix and prefer the pixel snapping, and some people don't notice it and have no idea what I'm yapping about. Me personally, I hate pixel snapping because I can't not notice it. It's always breaking my immersion, and it gives me a headache after a while because it's so jittery. When I was testing out my own pixel art game before I removed the pixel snapping, the jittering made me not even want to play my own game. So for the people commenting that this isn't a problem or I'm wasting my time, it is a problem for me and I will purge it from my game. Let's take a look at my 2D game in a 3D view. There is currently only one layer, which is the main layer, and everything on this layer moves smoothly because of the fix from my last video. But then, to be able to simulate the parallax effect, I'm separating out the background and the cages into their own layers so that I can move them independently. Unfortunately, the fix does not extend to these parallax layers, so while everything on the main layer will move smoothly, the cages and the background will still have pixel snapping. So that was the next problem I had to fix. The normal way of implementing simulated parallax is to code objects to move slower or faster relative to the main layer's movement, or in Godot, there are parallax background and parallax layer nodes which let us define layers and scroll speeds for those layers. Neither of these methods will work with my fix though. As part of the fix, we are moving the whole screen, or the viewport to be precise, by a calculated offset. Doing this allows us to make everything on the main layer move smoothly, but the parallax layers move at a different speed relative to the main layer, and we can't account for that when moving the viewport. Luckily, through the power of Godot, we are actually able to have several viewports, so we can set up each parallax layer in its own viewport. To do this for my background, for example, I cut everything related to the background from my game scene and pasted it into a new scene that I called background. Then I added a camera 2D to this scene to control what is shown, and then in the main scene, I duplicated the viewport container to add a background viewport container, and I made my new background scene a child of the new viewport. The viewports have a transparent property which we have to enable so you can see other viewports behind it, and now that I had individual control over the main layer and the background layer, I just repeated this whole process twice more to add a parallax layer for cages in the background and cages in the foreground. I then made sure each viewport container had my shader from last video attached. As a reminder, the shader just moves the whole viewport according to a variable called subpixel offset, which we will pass in through code. Now we just needed to update the main camera script to move the cameras in the parallax layer scenes, calculate their subpixel offsets, and send those offsets to the right shaders. That sounds a little complicated, but to show you how easy it was, for the background parallax layer, I literally just had to get a reference to the camera from the background scene, define a rate of speed for the parallax layer to move relative to the main layer, moving the background scene camera smoothly, the same way we move the game scene camera, but we'll also use our new rate of speed to achieve the parallax effect, then calculating the subpixel offset for the background camera, which is done the exact same way as the game scene camera, sending that offset to the shader that's attached to the background viewport container, and finally setting the background camera's position. I then repeated all these steps for the other two parallax layers I created. For the big reveal, I hit play and it didn't work at all. I was sure it would work since I'm copying the exact same process I did in my last video, the only difference being I'm accounting for the parallax layers moving at different speeds. I thought the problem might be that the shader was being shared by all the viewport containers, so I created an individual shader for each container, but that still didn't work. Eventually, after trying a bunch of different things, I discovered that the problem wasn't that the shader was being shared by all the containers, but the shader material the shader was assigned to was. So I made sure each container had a unique shader material, and when I pressed play, it worked perfectly. I am really happy with this result. All the layers move smoothly, no pixel snapping, and I can still use the benefits of upscaling. For example, this cage in the background is scaled down, but its pixels are the same size as the pixels everywhere else. It was forced to be pixel perfect because everything is aligned to pixel grids the same size, even if those pixel grids are moving at different speeds. It would be possible to add a toggle in the settings to be able to turn the pixel snapping fix on and off, and when I do eventually release this game, that's definitely something I'd like to add. I'm very passionate about getting rid of pixel snapping, but seeing the comments on my last video, there are also a lot of people passionate about keeping the pixel snapping, and if it's as important to them as it is to me, I would for sure like people to have the option. For me, being able to automatically pixelize things is important for lighting, physics-based objects, and other things like scaling objects. Having every pixel on the screen aligning to a singular grid is not so important to me, but I'm aware that it is for some people. Implementing smooth parallax like this means that not every pixel on the screen will align to a single grid. There are multiple grids that are moving and intersecting, and it's not so obvious when you're moving, but you might, for example, be able to see half a pixel behind a pillar if you're stopped, and you might think that's weird. Another good reason to have the option toggleable in the settings. I'd like to note though that Inmost, which is an imperfect pixel art game, has a clever solution for this that I saw the devs post on Twitter. When the camera comes to a stop, all the parallax layers shift slightly to conform with the pixel grid on the main layer. It means that you might see intersecting pixel grids, or mixels as people call them, while running, but when you're stopped, when the mixels are most noticeable, everything conforms to the grid. I'd like to play around with this in the future, and maybe take it one step further by having the parallax layer's camera's target position conform with the main layer's pixel grid to achieve the same effect, but I haven't got the time yet. That's it for this video. If you guys are interested in downloading the parallax fix files, they will be uploaded to my Patreon, but everything you need to take a crack at it yourself is in this video. Hope you liked it or found it helpful. If you did, please consider leaving a like or a comment. Thanks for watching.